oportunidade de nós recebermos os conhecimentos que ele tem na área de tecnologia assistiva, sobretudo na área de transferência de tecnologia. Então, nós vamos poder ter contato com o modelo, né, nessa área de transferência de tecnologia que os Estados Unidos atualmente conta, e certamente nós vamos aprender muito com esse modelo e possivelmente poder replicar, né, algumas dessas experiências, ainda que em menor escala, aqui no Brasil, aqui no nosso país, para que o Brasil também seja uma referência nessa área de transferência de tecnologia no campo da tecnologia assistiva. Então, a gente teve toda uma dedicação do CNRTA, da equipe do CNRTA, para poder ter o professor Lênin conosco, e ele aproveitou a ocasião de estar participando da REATEC nos próximos dias, não é? E para poder estar aqui conosco no CNRTA. Então sejam muito bem-vindos, espero que a gente possa aproveitar bastante a palestra e os conhecimentos que o professor veio trazer hoje para nós.
Thank you for inviting me to come here today. I will be making a presentation at a workshop tomorrow at REATEC that will focus on the details of the model called the need to knowledge model that integrates work from academia, it integrates work from industry, and it integrates a lot of experience that's come from attempting to successfully apply technology transfer in North America, Europe, and other places in the world. The concepts in the model are not only limited to assistive technology for people with disabilities. It turns out that any program that's attempting to generate knowledge and move that knowledge from conceptual ideas to practical applications in the marketplace, in society, is facing the exact same challenges. Those challenges, I think, and I'm here to present you my ideas about this, the challenges arise from confusion that has evolved over time as we have different people from different backgrounds using the same words to mean different things. I know today, thanks to you, we have our translators who are providing my words to you simultaneously in Portuguese. If only we had such a system when a scientist is talking to an engineer, and an engineer and a scientist is talking to a manufacturer, and they are talking to a therapist, and they are talking to a person with a disability. If only we had simultaneous translation, we might better understand each other. But we say one thing, another hears something different, and we all move forward attempting to accomplish something beneficial. So I understand I'd like to ask from the audience, because we tend to talk about stakeholders and we tend to talk about sectors. How many people here today are from universities? Would you consider yourselves faculty, professors? How many of you are from government agency that provides services or provides benefits to society? How many of you are manufacturers or work in the business sector? Do we have anyone from the business sector? What about clinicians, occupational therapists, physical therapists, and how many people with disability do we have? So we have a large representation from government, a slightly smaller representation from universities, and very slight representation from the other critical sectors necessary to deliver the products and services to benefit society. But that's okay, because this audience represents the critical sectors, government and academia. The society depends on us to to deliver benefits to the community. So it's most important for us, government and academia, to clearly understand what we're, not only what we intend to do, but what we wish to do, but what we actually deliver. That those two things need together. So I'm grateful that you're government and academia, because I think you'll understand the talk I prepared for this session, which is a bit more conceptual, it's a bit more scholarly, but it's the underlying terms and concepts that drive everything we try to do in technology transfer, commercialization, and providing social and economic benefits to society. So the title of the talk is 3 Methodologies and 3 States of Knowledge, all that underlie technological innovation. So I'll see if I can make my points here. There's actually 3. Technological knowledge exists in 3 different states. There's conceptual discoveries. That's one state. I conduct an experiment, I have the results, I know what the results are, but all I can do is tell you the results. I can communicate them. I can stand here and tell you them. I can write them down in a manuscript and have it published, and hopefully someone will read the work. But that's all it can do. It's a conceptual discovery. The second state of knowledge, you can take a conceptual discovery and reduce it to a practical form. So a prototype of an invention is a different state of knowledge than a conceptual discovery. And a commercial innovation takes that same conceptual idea, that same kernel of knowledge, and moves it into a product like a PC, an iPhone, a microphone, a chair, a table. It's still that same kernel of knowledge embedded inside, but you don't see the knowledge anymore. It's a function, and it's a function that provides a service. So, to me, it boils down to something this simple. I work at a university, but for the past 20 years, my focus has been transferring technologies to the marketplace. So much of my work is with manufacturers, it's with inventors, designers, it's looking at the shop floor, it's looking how to fabricate something, it's talking about tools, it's talking about dyes, it's talking about molds, it's talking about quantities of raw materials that are transformed. So even though I'm at a university, I come from the application of technology in the form of products. And then I'm trying to understand, what does this mean that I can communicate to people in universities and people in government who really control the resources and actually determine what occurs in society. So the best I can do is boil it down to that when we say, well, we want to create new knowledge to benefit society, and when everyone typically thinks of new knowledge, they think of scientific knowledge. So we give the money to universities to think great thoughts and to do great work. But that's can only deliver the first step, the first state of knowledge. We need to step back and say, it's all right, it's okay to generate knowledge also and use government funding and university support to generate knowledge as a prototype invention, because it's knowledge, it's still knowledge in a different state, or as a commercial innovation. So it's still knowledge, and I think that's an important issue because government tends to think only funding activity that generates knowledge coming out of one methodology. So the second key point is that there are 3 methodologies, and each is designed to generate knowledge in only one state. The scientific research methodology generates conceptual discoveries. That's what it's designed to do. It's designed to control variables, control some variables, manipulate other variables, and look at the results. Whether it's a causation or a correlation, the resulting data from the study said there's a relationship between this factor and this factor. That's what the scientific method is designed to do. The scientific method does not generate prototypes, nor does it generate commercial products. So it's one method generating knowledge in one state. Engineering development is a separate methodology. How many engineers, how many people here are engineers? You are underserved by our language. We'll talk a little bit later about why that is. It's a historical artifact. But truly, the practical application of engineering has lost its status in society. You've been marketed differently, and the development has been linked to research in the R&D, research and development, so that we've diminished what we refer to as large R, small d. And really, you need large D to go along with large R. Industrial production is another method. If we had anyone here from industry, they could tell you all about their methodology. And they'll say, yes, it draws from scientific discoveries, and yes, it draws from engineering prototypes, but there's an entire additional set of activities that must happen before that conceptual knowledge and those prototypes become a product. You know, there's design, there's specification, there's materials, there's marketing, there's cost. And unless the system supports the creation of products and the delivery of products to the marketplace, we're not delivering the knowledge to society. Especially when we're talking about technological knowledge. Usually, when I talk about this, people who come from university listen politely, and then at the end they say, so, you're against science. I say, no, I love science. Basic science generates all the knowledge of our world. But if we're talking about social and economic benefits for society, it's simply not enough. It's simply not enough. My opinion is that successful science, technology, and innovation policies, what we call STI policies, require clarification between and parity, equality among these basic concepts. To me, this is it. This is all we need. I like things in threes. I would say I do a lot of things in threes. I can handle threes. I can't handle 12. But to me, it all boils down, when anything I read, any policy papers, any plans, any legislation, I can just boil it down into these simple things. Which type of knowledge are we intending to generate? Which methods are we applying to do so? And to what extent is it benefiting society? It can be just that simple. So I guess the important thing is, why is this important to you? And certainly for the people here at CTI, I think it's very important because you're tasked with creating the CNRTA. And the CNRTA in Brazil is very much like what Australia is trying to do with the National Disability Insurance System. So they're trying to create a national network in Australia because they don't have such a network. And they're doing that right now at the same time. In Europe, they've been working on developing a network of the European Union countries for the past 25 years. In the United States, this effort started in 1974. So 40 years ago, the National Rehabilitation Act was passed at the federal government in the United States to create an agency, the National Institute on Disability and Rehabilitation Research. That organization funds me. That organization funds most of the work in assistive technology in the USA. The National Science Foundation funds a little bit, more on the technological application side. The National Institutes of Health funds a little bit, but more in the basic biomedical area. The United States Veterans Administration funds a little bit for military soldiers who are injured in war or return. But the agency that funds me was an agency that was charged with generating an array of programs in the United States to serve people with disabilities and provide beneficial outcomes for them. So it's been 40 years. So I feel like I'm coming from the future to ask you to do better, because we have not done a very good job. And I'll give you some data that explains why that is. But your national network is supposed to be both research and development. So I'm listening for, okay, how much science and how much engineering? How many conceptual discoveries that are written in papers? How many prototype inventions that are tested and tried and patented? That combination will determine how much commercial innovation occurs, and therefore how much impact these programs will have on people with disabilities in Brazil. So getting that formula correct is critical to the amount of success that will be achieved in Brazil. And certainly it's been critical to the success or lack of success we've had in the United States, in Europe, and Southeast Asia, because there's been programs in Japan. There's a program similar to this. They're mainly benefiting government and academia. The more money government gives to the government program in the U.S., the bigger the organization becomes. The more people it hires. And the people who were hired first move up. So more money is good for the government agency. They give that money to universities. The university professors need to write and publish in order to receive promotion and tenure. So they focus on writing papers first, because that's what rewards their career. So our program has been very good for academics. We've improved the quality of life for faculty members in the U.S. I can say that clearly, without a doubt. We have not benefited industry or society in 40 years. We have not truly impacted. Industry remains on its own, doing the best it can do. Consumers remain on their own, trying to find the technologies and hope it's the best technology. We tried to move the field out of the medical model and move into a social model, which we are successful in doing in terms of law and accessibility, like ramps and cuts and curbs, but we left the technology behind in the medical model, and we never provided for support for the clinicians that need to provide the services. So we have companies, many of whom will be at RIATOC. They're trying to provide products, but the government says we'll only pay you so much money. So there's a ceiling on the amount of new technology they can introduce, and the amount of innovation they can introduce, because they can't be given another dollar. They can only get what they get. And then the consumer who wants to buy that piece of technology is only reimbursed a certain level by the government. So the real ceiling, the real barrier to innovation in the field of assistive technology is the caps on support for industry and the caps on reimbursement for people with disabilities. But we're not seeing caps on government or on academia. So somehow I speak about the balance, the parity between these organizations. The ironic point here is that the government people have career appointments. Right? After a period of time, they've been employed forever. Most of them forever. They stay a long time. And same with faculty. They have a job. They have a study, it works, it doesn't work, that's okay. We'll do a new study. But they have a job. The two groups that are most vulnerable are corporations and people with disabilities. They have no guarantee. They have no permanent position. Yet they're the people who are most neglected. The funnel of the money narrows when it moves to industry and society. So I'm hoping that the plans you develop, the programs you implement here, keep that in mind, that unless you're addressing the needs of people with disabilities and industry you have to accept that your program will mainly be benefiting the government agencies that pass the funding and the academics who conduct the research. That's only one, that's delivering one type of knowledge, but it's not enough. And that's why I say, I think you can do better than we have done. Here's my organization, the National Institute on Disability and Rehabilitation Research. This is the 2013 report. So this is 40 years into the activity that's supposed to generate products and services to benefit people with disabilities. And they proudly show the number of scholarly papers that they've produced, the number of presentations they've made, large numbers. And then you say, okay, but what about delivering results to people with disabilities? And you look over to the right and you see much lower numbers. I think it should be reversed. I think the basic science agencies in each country should be funding the first two, but the agency that funds me, and I think somewhat the agency that the organization you're creating should have much higher results at the other end. And I'm not happy with this number. And I will be in Washington in 2 weeks, again, speaking to this organization that funds me about my unhappiness with the number, and still trying to work to change the process to make it work better. The difference is budgets, our budgets are contracted. They're being reduced. So there's less money. As money gets tighter, everyone looks around and says, well, what are you doing with your money? What are you doing with your money? So we're having more questions about what benefits is society getting. So I think there's more pressure to do more of the market deliverables than the scholarly deliverables. And even the numbers on the right, I can challenge because the new path to market is apps, right? People can now develop their program, put it in the app store, and say, we've transferred our technology. So it's a bit of it's gaming the system a little bit. They're not tracking, is anyone downloading the app? Are people happy with the app? If you have an app that allows someone to read a computer screen, how does it compare to all the other apps that already teach people how to read a computer screen or help people read a computer screen? It's the effort should be on the creator to demonstrate why this new product is better and needed in the marketplace. So basically, I want to walk through some things with you. It's sort of a typology of knowledge states. We're going all the way back to ancient Greece. We have to go back 2,000 years to the point where they really had this right. And then over time, it went wrong. We're talking the evolution of the structural methodologies that I just mentioned, the gradual commingling of the sectors, the methods, the outputs, and the terms that sort of put us in the position where we're in now. How those conflicts were resolved to the benefit of some groups, and the sort of the muddled mess where we are now, where people use the same words to mean different things, and politicians get up and they say we're going to double the funding to solve the problem, and it really has no link to actual activity and actual results. And then just a brief mention to return to where I started about generating some common sense, some simple understanding of relationships between these methods and their outputs to really deliver something of value to society. So we'll start with the methodology, but before I go further, does anyone want to say something? Does anyone want to ask me if I'm anti-science? If not, I'll continue on here. My basic was Aristotle. Of course, Greece was small. There weren't many people thinking. Very few people had the time to sit back and think. But Aristotle certainly did. And Aristotle thought very much about what is this thing we call knowledge? What is, when we sit around in the Senate and we think about ideas and concepts, what are we really talking about? And he said there were 5. I like 3, he likes 5, but I'll reduce it to 3. He said there were 5 different virtues, what we call virtues of thought, that what I consider states of knowledge, especially in the technological sense. Technia, epistema, phronesis, sophia, and nous. And the last 2 really deal with more the the ethical and aesthetic aspects of knowledge, art, music, but some of that is imbued in the other three as well. 3 of those 5, to me, represent the core elements of technological innovation. Aristotle defined episteme as representing that body of knowledge or system that provides a basis for generating concepts. And that's the conceptual discoveries. I said, I get that. I understand what he's saying. He said techna represents a body of knowledge or systems that provide skills to do or create something tangible. That's reducing it to practice. To me, I say that's a prototype. It's somehow figuring out how to combine materials and power and craftsmanship to make something. Then we get to phronesis. It takes the skills of both. So it takes the facts of episteme, it takes scientific knowledge from and it takes engineering skills, and it combines them to improve the quality of life, a product and its experience. So to Aristotle, it's not just the creation of a musical instrument, it's the sound the musical instrument makes. Both the instrument and the sound are aspects of that form of knowledge. I think it's just a beautiful way to conceptualize states of knowledge. And this was 2,000 years ago. And I think Aristotle was exactly correct. And what happened? We saw over time, over the 2,000 years, the methods of episteme, the methods of generating facts and knowledge became the scientific research methods. You knew you had to control the variables, otherwise you couldn't understand the result. You couldn't have confidence in results. You knew you had to be very particular about your selection of materials and control the activity. You knew you needed to be able to replicate the experiment. All the aspects of the scientific method arose by refining the approach to generating factual knowledge to what we have today. We're pretty certain that when we generate new knowledge from an experimental study, a scientific study, that it's correct. You know, we saw that recently with the Higgs boson, where you have people conducting experiments with super colliders to see if they can detect this particular form of energy, or with nuclear fission and fusion. You have to have experiments that can demonstrate and replicate something that's done. So this method, the scientific method, clearly is intended to generate the state of conceptual discovery. And I use the word novel conceptual discovery because in the world of academia, you have to come up with something new in order to be recognized as worthy of publication. So you have to know what everyone else knows, and then you have to pick an area of activity that you can contribute new knowledge, and then you publish it and say, I have produced novel information that's adding to the knowledge base. Now, the scientific method is designed to generate objectively observed knowledge in the state of conceptual discovery. It's the new to the world articulation. It's the first time someone announces the presence of a fact. Do any of you know the book, The Diffusion of Innovations by Everett Rogers? It's a book that talks about the diffusion of innovation, how innovations move into the marketplace and into society. But Everett Rogers was a sociologist. So his main concern was how individuals and groups react when they're presented with knowledge that's new to them. So if I've never seen an iPhone before, it's new to me, but it's clearly not new to the world. So we have to be careful. He used the word diffusion of innovations, and as a sociologist, I think he used it in a manner that did not help us in our understanding of innovation. When we talk about innovation, we need to think about new to the world, new to everyone, as a true innovation. But a conceptual discovery is a know what. You know what? I'm here talking to you. It's a fact. It's a know what. It's something that I didn't know until you told me or I read it. Its primary value as intellectual property
is it's described in a paper or a presentation. That it's an intellectual, it's a form of intellectual property, but only in the form of the paper itself. The ownership and control of that intellectual property is protected only by international copyright law. If I tell you something that I discovered yesterday, the only protection I have is copyright law. It puts my name on it, and it says, as of today, I'm saying that I did this work. If you go and say, as of tomorrow, I did this work, I can say, no, I was first, it's mine. But it's only protected by copyright law. That's important to think about the demonstration of the 3 states of knowledge. So it's new to the world knowledge. It's empirical analysis to reveal novel insights, which could come from either the curiosity of the investigator or a request from society to do the work. So when people talk about science push or market pull or supply push, demand pull, it doesn't matter. It's a false argument that we spend too much time debating. It doesn't matter. Both forces exist together. It is a conceptual discovery as a manuscript and presentation, the know what. It's copyright protection only, and it's value. And that's we're back to talking about value. Why are we doing what we're doing? What is the value to us and to society for doing the work we do? It's a new relationship or effect which is now contributed to the knowledge. You now know something today that we did not know yesterday. But that's all we can say about a scientific discovery. In and of itself, its value is as new to the world knowledge that enlightens us, tells us something new. At the same time, Aristotle's techna gradually evolved into the engineering development methodology. That when engineers go to school and they become professional engineers, they're trained in the methodologies of electrical engineering, mechanical engineering, aerospace, biomedical engineering. They all have their own methodologies, which are different than the scientific method. So it's a second type of methodology that continues to represent what Aristotle called technique. The output is knowledge in the state of a tangible invention, a new creation. But as we said before, it's a prototype. It's not a final product for the marketplace. It's designed to generate predetermined functional outputs in the knowledge state of a prototype. It's not ready for you to take home, but it proves that it can be done. And it's new to the world. It's know how. Instead of know what, it's knowing what. This is knowing how. I know how to make this. I know how to build this. So it's an application of the conceptual knowledge in a practical form. This type of knowledge, I argue, is a different state of knowledge because it's protected by a different form of law. Our societies recognize that intellectual property in the state of a prototype invention from engineering development methodologies is protected differently than the output from the scientific method. The output from engineering development is protected by a patent. It controls the ownership and the rights to practice that patent to the person who created it. So people say, well, how do we know we're talking about different states of knowledge? I can point to these things and say, we can clearly show across the same points why we can call knowledge in invention a different state than what we call knowledge in the form of a discovery. It uses the engineering development method, which is different. The process is a trial and error experimentation where you may not be trying to control the variables, you're trying to manipulate all the variables to make it work. And a prototype may not be practical in the marketplace because you might have to use very expensive materials, or you might have to make a very large mechanism to demonstrate that it works, and then all that is eventually reduced to a practical form. It's to know how, and that's what a patent says. The patent says, I claim the following. I claim I know how to make something that no one else has ever made before. And that's the whole purpose of the patent. Now, the value here is different, but it's additive. The value of the invention state of knowledge is it's feasible now. You've demonstrated that it's possible to make this work. In addition, it's still a novel concept. So you take the novelty of the conceptual discovery, and now you add the feasibility of a practical form. That's the demonstration of a patent. You have to show that it's novel, and you have to show that it's feasible. The big example people use is you still cannot obtain a patent for an anti-gravity device because it's not possible. You have to demonstrate it's feasible. So it's nice that we have a different set of law and a different set of value terms representing knowledge in this state. Now, Aristotle, in his time, there was not a lot of heavy industry. It was light industry. Over time, industry evolved and grew, and they have their own methodologies. There's an international organization called the Product Development Managers Association, and they have a whole series of books. They have all kinds of literature that says these are the best practices to accomplish some form of manufacturing of a new product or service. That's standard methods used throughout the world. Yet, most people who are working in our field of applied technology are not familiar with the methodologies of industry. The concern there is if they're not familiar with the methodology, they don't know the constraints, they don't know the limitations, nor do they know the requirements of the methodology. I talk to many academic scientists, and I say, would you trust the results of an experiment that did not control the external variables? Of course not. I said, would you trust data analyses on the behavior of people that involved 3 or 4 subjects? Well, no. You need enough subjects to do statistical analyses to show the power of your result. I mean, scientists know this. But when you ask the scientists, what is the industry standard to conduct a focus group, to get input from people in the community about the functions and requirements of a product? They don't know. They simply don't know. If you go to a company and say, I conducted a focus group, so I'm telling you that this new wheelchair is the best. The industry says, how many people? You say, well, I invited 3 people I know with wheelchairs, and they talked about it. Well, that's no more than doing a data analysis of 3 subjects. It's simply not appropriate. Industry knows at a minimum you need 3 groups because there may be an extraneous factor that influences one group. So you need multiple groups. You can't just have one. You need to have a selection of people. You need a purposive sampling of people, some with high experience, some with low experience, some with no experience. You may have the group selected by age, by disability type, by career potential, by education, but you need to do that in advance. You just can't simply invite people off the street. You need to have a trained moderator that's running the group. You need to have a script that's followed. And there's methodologies like the Kano methodology. That you introduce a series of concepts in the group. You talk about the expected attributes of this cup. And then you move on to the exciting aspects of this cup. Well, what if it can do this? Then you move on to revealed. You move on to things that the people in the group never thought of before. That's a structured method. But if the people trying to do assistive technology research and development don't understand the industry standard, the results of their work will be rejected by industry. Any more than an improperly controlled experiment will be rejected by a journal for publication. It's simply not acceptable. So in order to move this notion of technology transfer, in order to move knowledge from the state of concept to the state of prototype, all the way to the state of a product or service, we need to understand all those methods. And we need to know their opportunities, and we need to know their constraints. Because the purpose is to generate a commercial product or service as an innovation in the marketplace. So we have the same thing. It's designed to deliver outputs as a commercial innovation. And now the attribute, it's why. Why am I doing this? It's no longer a know what or a know how. It's to know why. What's the motivation for me as a company to manufacture this new product? And what's the motivation for you as a consumer to acquire this new product? If I don't understand and know why, my knowledge is not yet ready to be applied. So it's a different way of thinking about knowledge. Interestingly, ownership and control of intellectual property is protected by yet another form of law, trademark. It's no longer about the patent. It's no longer about the copyright. When Apple puts out a new device, it has the Apple trademark, and no one else can use that. When Nike puts out a new running shoe, it has the Nike mark. So the symbolism attached to a product or service is protected by trademark, which may be on top of the patents, which may be on top of the copyrights. But it's clearly treated differently. Its purpose is to codify knowledge in products and components positioned as new or improved products in the marketplace. We see a lot of what we call reinvention. It's already out in the marketplace, and someone else comes along and tries to produce the same thing. They didn't do good market research. They didn't know someone had already brought it to the marketplace. It's a problem with inventors. They have an idea. They get excited about it. They spend all their money on the idea, and they borrow more. And then they come, I have my product, and you look at it and say, well, there's one here, there's one there. It's a complete waste of the time and effort. And even more critical, they spend money what we call reinventing a square wheel. It's a bad version of what's already available in a good version. Tremendous waste. And when we're talking about assistive technology or many other what we call niche markets or orphan product markets, we don't have the money and the time to waste. We need to focus our intellectual capabilities, our engineering resources, and our industry on delivering the best products we can, because otherwise we're simply wasting the money. It's a systematic specification of components. See, this is a very different process. It's no longer, we already know what we know conceptually. And now we already know what we know about engineering, about materials and components. Now we say which materials, which components, combined in what way to deliver a product or service. So this method has a very different purpose. It's embodied as a viable device within a context. You make a product for a purpose, to serve a function. And it's an opportunity presented by the market. Now, most mass market products, the opportunity is there. For assistive technology, the government often has to fill that opportunity by providing the resources and support to make it worth the time of the company to produce the product and allow the person who needs the product to acquire it. So in periods of market failure, we need the government to intervene in market innovations. It's trademark protected. And now we've added the third component of value. And when you talk to a company will ask you, what's your value proposition? And you need to know what that means. So when you're presenting the value proposition, a business plan, or an opportunity to a company or to an investor, you have to be able to explain that it is novel, so we don't have to worry about someone else competing with us. It is feasible in the context of the cost of production and delivery of the product or service. And you have to define the utility. How useful is this? How useful is this to the company who produces it? It has to be useful, it has to generate enough income, revenue, to keep my company in business. If it doesn't, I can't make it because I will be out of a job. So the government could step in and say, we will help you make that market utility argument. We will subsidize your work. We will help you make it. And it has to be useful to the consumer. If I don't think a product is useful, why would I buy it? So this form of knowledge has to meet all three levels of value in order to be successful. At a minimum, because it still has to be in a competitive marketplace. There's still other opportunities. There's always new technology evolving. So all we're doing is trying to increase the probability of success. There are no guarantees with transfer, commercialization, innovation in the marketplace. But we can certainly do a better job of increasing the probability. If we don't carefully apply these methods, we reduce the probability of success to the point you saw on the chart where there's a lot of publications and very little transfer onto the marketplace. That's simply an artifact of not doing it correctly. Now, government funding for knowledge creates two tracks. And it's important to recognize that both of these tracks work very well. Track one is grant-based scientific knowledge. So the government program says, I will give money to you as an academic researcher to generate new knowledge in the state of conceptual discovery. That's fine. That's what most government funding for new knowledge is for. It's grant-based scholarship. A grant is given to a university, and that money goes to the faculty, and they conduct the work. There's so much money, so much time to complete the study and deliver the results. Grant-based scholarship, how do we know it's good? Well, you have a peer review system. You have other scholars who are watching, they're reviewing the proposal, then they're following the work, then they're reading the paper, and they have to say, it's good, we can go. And you have to publish it, and publish enough to achieve tenure, to receive job security. This is a system that people think I'm against. It's a wonderful system. It works great. We have advanced the state of knowledge in our civilization immeasurably through this very system. It's perfect, just the way it is. I wouldn't change a thing. The second track is a very different track, and we don't think about this one. It's a contract-based research and development for production programs. This is not about generating new knowledge in the fields of science and medicine. This is about generating products, deliverables. It's typically more military defense, energy-related, nuclear energy. So you don't give a grant to someone to build a nuclear submarine, right? It'll never happen. You have to have a contract. You have to say, here's the requirements. This must do the following functions. And it must be delivered in the following milestones. And it must be done within a certain time. It's a very different system. It's not a grant, it's a contract. So we're talking about contract production. Now we're all the way over in the industrial methodology. And it's not a peer review, it's performance specifications. Either the product performs as it's supposed to, or it does not. And we see this all the time in aerospace. I think it's most obvious, where you have international competition over the Airbus and the next type of aircraft. Can it perform the way it's supposed to perform? Or is it experiencing failures, at which point nobody will buy it? So it's all about the performance specifications, and it's not about publishing for tenure, it's about selling for a profit. That's the system. In this case, it's not an open market. The government gives the money to the company to build the airplane or the submarine or the army tank. And when it's built and it meets the specification, the government buys it. So it's a closed market. The government funds the work at the front end, and they purchase it at the back end. That's its own system. They work very well because they have their own expectations, they have their own systems and incentives, and they're all aligned. Everyone understands the system. Everyone in academia understands track one. Everybody in aerospace and defense industries understands track two. They're very clear, and they work very well. The government grants versus contracts have to be considered differently. The grants are the open exploration of new ideas, whereas contracts have to deliver something very specific. And typically, most grants go to universities, and most contracts go to corporations. There's a little bit of experimentation at the edges, but we're not seeing a lot of success either way. The grants not only pay for the work, but they pay the university institution the administrative costs. So the university benefits and the faculty benefits from receiving the money. The contracts pay a profit to the company above the cost of doing the work. So the company benefits and the professionals benefit. Again, both systems independently work very well. Now, all these methods, research, development, and production methodologies, they each have values. And the values are different. They each have a unique purpose. They have underlying principles and assumptions. The educational requirements to do each type is different. You get a PhD to do scientific research. You become a professional engineer to practice engineering. You get a master's in business administration to be a product manager. So they have different courses of training. Some people cross over. And there's a certification of mastery, and there's a certain legal status that goes with each one of these fields. Each type of output is valued differently by the actors within society and as society's expectations for their contributions. If we keep them straight and understand what we say we're going to do, and we have the method to do it, and we deliver the results, that should be fine. So what we're talking about here today is when it doesn't work. Aristotle was talking about pure typologies, the three types of knowledge. In the modern world, all these interest groups have coalesced and sought to influence all three states of knowledge because there's money and there's power related to each of those states of knowledge. Many of you know Marcos Pinocchi. I only met him last fall, and in the fall he did a presentation about values. And if you know him or even don't know him, you might ask him for a copy of the PowerPoint. It was very correct, but very amusing. He took one example, and he explained how the government person perceives that example. And they talked about how the university faculty person perceived the example. They talked about therapists, they talked about consumers. It was very well done. And looking into his background, I understand why he's so good at that, because he's extremely effective in the work that he does. His projects are at a very high level of technical progression, and his projects are teamed closely with major corporations and major international funding organizations. So I told him in an email that I was going to use his picture, but I was going to stretch it so he looked fat. Now what happened, even though we created these methods, is we had a gradual commingling of all of what I just talked about. It should have been easy to keep all these things straight, but we're talking about money and power. We're talking about personal incentives. So things get a little crazy. From the 1880s to the 1930s, inventors and companies